Now let's look at stoichiometry, the quantitative aspect of chemistry. Let's go through it. So, in chemistry, okay, everything is about the number of moles. Very important. So, if I give you information about mass, you must be able to change that information into number of moles. And the formula the relationship between mass and number of moles is given by this formula here. So it's given by that formula there, which says number of moles is equal to mass over molar mass. Now, particles, number of particles. If you're given number of particles, should be able to change them into number of moles. Or to get number of particles, you must have the number of moles. So number of moles is connected to each and everything that is happening here. All right. So you can't do anything without number of moles. Volume is STP. If you want to calculate volume at STP, you must have a number of moles. Or if you are given volume at STP, go and calculate number of moles if you want to go anywhere. So our number of moles, they are a transport, actually. They act as transport. If you're given to a transport to move from one substance to another, you go via number of moles. So if you are given concentration, you still do the same. So this is your information sheet. Okay, I encourage learners to go to the information sheet and say, and write here in this column and say particles. So I encourage every learner to say, they should go to their information sheet and say, particles must concentrate at a steeping. So they must say, particles must concentrate at a steeping. Particles we are referring to molecules, atoms, ions, and formula units. Those are particles. So if you go use and do it like this, you will. These are the key words that inform you which formula should you use. So if you are given mass, you can get number of moles. If you are given particles, number of particles, you can get number of moles. If you are given concentration, you can calculate number of moles. Right. Now, if you are given, if they say STP, it means you're going to use this formula STP. Now, when the question talks about number of particles, it means the formula that applies is that one there. But before, make sure that you calculate number of moles. If you check, you realize that every formula has got the N here, N here, N here. N is part of every formula. And every formula, it means you need number of moles. Number of moles are the most important things. Right. Right. One thing that you also need to know is if you are given any information about a limiting reagent, if you are given information about a limiting reagent, that information that is given, make sure that it is in moles. So you change that information into number of moles. Okay, then change those number of moles, then use ratio, then use ratio to get information about other substance. Now, if they give you information about product, change that information into number of moles. Then use ratio to get information about other substance. Now, if they give you information about the excess reactant, now get the reacted number of moles. Get the reacted number of moles for that excess reactant. Then you can use now ratio to get information about others. Okay, so that's very much important. So now, if they give you a graph like this, it starts with a certain amount, then decreases until it becomes that. This graph here that we see, if you have a substance called B, you will realize that the graph is, you start with something, a certain amount, then that amount decreases until it becomes zero. So this graph represents the graph of a limiting reagent. It means the substance that will be the site will be called the limiting reagent. Now, if it is like this, right? Now, if you check this substance here, okay, it does not, whatever the substance it is, let me just call it a B, let me just call it A. Whatever the substance is mentioned here, you will realize that the initial amount of that substance is this. Then it drops until the graph is straight. And when the graph is straight, it means the reaction has stopped, right? And then it means now, if we check very well, the amount of substance will be appearing here as a 10 amount. Now, this graph represents a substance that is not finished. It is not completely used up. Here, the substance drops until it becomes zero, until its amount is equal to zero, right? But this one drops and it does not drop to up to zero. So this one represents the graph of an excess reactant. It is the graph of an excess reactant because it's not completely used up. Right. So this will represent the initial amount of the excess, and whatever the value is here will represent the remaining or the leftover amount of the substance, the limiting, excess reactant. Now, if you see a graph going like this and then becomes flat. Right, what is happening here now, this certain amount here, this amount here that is produced, this is a, we can say that it starts from 0 until it gets to a certain value. So this is a graph of a product, because always a product starts from 0, right? It starts by being 0, meaning there is nothing in the beginning, right? So whatever the substance is here, that substance is a product, and the amount of the product that is produced is indicated there. There. Right, let's look at this question. Okay, so we read magnesium reacts with 30 grams of hydrochloric acid, HCl, according to the balanced equation. So we see the balanced equation and then in the graph. Then, right, according to the graph, this is it. The graph shows the mass of magnesium. Okay, so it says in the beginning,